In this video, I'm going to introduce three definitions and a postulate. The definitions are, things that we are pretty familiar with, but they'll be stated in a little bit of set theory. So again, anything between these squiggle braces at the end, the stuff inside tells me what's in the set. And so here I'm saying that I take the line segment from A to B. I take the line segment to be the set of all points between A and B, right? So if P is some point, like that red dot, in between A and B, then it is included in the line segment. Notice, by the way, that because A is trivially between A and B, then therefore the point A is always an element of the line segment from A to B. I define the ray as having everything that the line segment has. You can see that in this picture of a ray, union together with, so I'm using again this set theory notation of union, which just means kind of throw everything together, right? Collect it all together into one big set. So I also throw into the ray all the points that are on the other side of B, which I express mathematically as the set of points for which, right, P is that point for which B is between A and P, right? There are many such points P. Collect them all together, and the union of all of those sets is the ray from A through B. I also define the line through A and B to be the union of the two rays, right? So the one ray will go off to infinity in one direction, the other ray will go through the same points to infinity in the other direction. If we union those together, collect them all together into a single line, then that's the line through A and B. The additional postulate will gain us a lot of facts about Euclidean geometry, and it's the ruler postulate, which says that every line can be identified with R, the set of real numbers. R has 0 and 1 and -1 and square root 2 and pi and all of these numbers that we are pretty familiar with in high school geometry or high school math classes. We will also define the notion of a coordinate. So what this means is every point gets paired up with a real number, right? So the point A perhaps gets assigned to the real number 0, right? So if this is our line L, every point can be associated with a real number, and so I can put 0 here where A is, and 1 where B is, and so on, and we call these the coordinates. So A has coordinate 0, B has coordinate 1, C has coordinate 2, and we also, maintain, through this association of points with the real numbers, we maintain the ordering of them and the distances between them. So by choosing my distance metric to be the same distance that the real numbers have, then this means that the distance from A to B must be equal to 1, and the distance from A to C is 2, and so on, so that the distances are defined in terms of distances on the real number line, and because we know that those the numbers in the real number line have the typical ordering that you intuitively believe and understand, this now gets us a lot of the Euclidean geometry properties. And here I state a theorem, and I think probably for you, the viewer, it's good to try to prove it before I do so in the next video.